Hi students. So today we are also going to look at AP Computer Science. Okay, AP Computer Science is a course that we teach to students in high school. Okay, typically in their junior year or senior year. Okay, now you can take it anytime. Okay, or even earlier. You can take it in your sophomore year also if you so choose. It depends on you. Okay. So, um, our company Gnosis Learning develops learning classes for students. Okay. Now, AP Computer Science is one of our favorite classes. This is the second year we are offering it. Okay. You can download the application onto an Android device from this link, apexams.us/computer science. Or I will show you where in the Google Play Store you can go. You can visit our AP www.apexams.us and you go to computer science and you will get the class. Students who are interested in learning Python as part of our program can go here. Otherwise, you can go to this link and download it directly from the Google Play Store. But you should do that so that or you can look for it in Google's Play Store. This is the link, com.nyanamarga.ap6. The Google Play Store. You can download it onto an Android phone. We do not work on iPhone or on iPad. We use a Android device like an Amazon Fire or a Samsung Galaxy. We also teach our Python course, and these two courses we are offering to students abroad, but we will be providing the American version as well. Okay, so typically an AP Computer Science class is a year-long program. It contains the first maybe 6 units are taught in the first semester. The remaining 4 units are taught in the second semester. The first 6 units teach you the basics of the programming language Java. But before you learn the basics, there is also a unit 0, which teaches you about computers and the whole environment in which Java programs are built and Java programs are run. Okay, so in the second semester, the first 6 units in the first semester, 7 to 10. The second semester builds on top of the first semester. For instance, first semester you learn about arrays. The second semester you learn about two-dimensional arrays. The first semester you learn about objects and writing classes. The second semester you learn about inheritance. In the first semester you learn about iteration. In the second semester you learn about recursion. So you slowly build your expertise by learning things in a certain order, and then there is a certain dependency between the units of the course. Okay, so learn the early material well first before you go to the advanced. So typically this page is directly out of College Board, so you can go and look at what the lab requirements and download the lab student guide. You can also get the Java quick reference. Right now it may not make that much sense. You can get additional resources available. Students who take AP Computer Science should note that to score a 5, only 24% score a 5. It is good to score a 5, particularly if you're going to be applying to data science. If you get a 4 or a 5, that's kind of standard. If you're going to be applying to data science or computer science. Typically, some students take both AP Computer Science one year and AP Computer Science Principles the following year, or sometimes they may take one of them through the by just taking the exam. But it helps to take it in a school setting and work with us as a parallel effort. And when you come to our live lectures like this one, or the live lectures that we teach on a weekly basis during the weekends, and then you can work with us in building some programs. We assign some homeworks, but we can also help you, if you write your own programs. Okay, we can also help you there. Okay, so this is AP Computer Science. Now, one of the first things you need to understand is what is a computer? How do computers work? Most modern computers were built based on the model developed by John von Neumann. Okay. Now, John von Neumann was a genius, and he helped the United States win the Second World War and defeat Nazi Germany. John von Neumann computers are practically used in almost every computer today, including the laptop I'm using to make my this lecture, as well as the cell phone in all of your hands and in this cell phone. Almost every device that you know, electronic device, uses a von Neumann computer. What is a von Neumann computer? Von Neumann computer is a machine built with millions of tiny switches called transistors. A transistor typically is a gate, involves a gate which stores 1 or 0, or which involves 2 inputs and 1 output. So that is, a transistor typically has 3 polarities. Okay? So now a von Neumann computer contains this is an abstract and very simplified model of a von Neumann computer. In a von Neumann computer, there is what is known as a central processing unit. Central processing unit contains a set of logic which executes instructions. What are these instructions? These are machine language instructions, which are really binary numbers. These machine language instructions are loaded from what is known as memory. In addition to CPU, you also have memory. This memory is fast, random access memory. So typically what the CPU does is, the CPU has a set of its own scratch pad memory called registers. It loads data from RAM memory onto registers, and then stores it back into RAM from the registers. Okay. Now, when it wants to get a particular piece of data, it places the address, on the address bus, and then the data is read from there. When it wants to store data, it takes data from a register and then it places that in the data bus and specifies the location where that data is to be stored. Okay, so there are many types of machine language instructions. We already looked at 2 of them: load and store. There's also branch instructions. So what does the CPU do? It executes machine language instructions in sequence, but sometimes it wants to go to a different location and then execute from that location. The term location and address are synonymous. So it will be executed one after the other instructions, then it will jump to another instruction. That is known as a branch. So in addition to load, store, and branch, there are also ALU instructions, which are arithmetic instructions like add, subtract, divide, multiply, and etc. If you had 2 registers, you can add the result and place the result in a third register. A plus B equals C. Those kinds of operations on using the scratch pad of registers in the CPU. So that is also part of the logic in CPU. Okay. Now, mostly what data stored in memory is stored as the 1s and 0s, and each piece of data is called a bit. Now, when you have groups of bits, 8 bits, it equals a byte. Okay, so now when we look at the parts of a computer, right, we look at the CPU and then we look at the memory, and then there are various peripheral units like display, keyboard, network, disk drive, etc. Now, these peripheral units are what are called input-output units. Sometimes, but so far when we looked at this CPU and memory, that's this CPU and memory. That was just a very simple model of the same computer. Now we include the whole model. Typically, the computer also has a disk drive which has permanent storage. It could be solid state disk or it could be magnetic disk. Data from the disk drive is loaded directly into memory sometimes, and then from there it is executed by the CPU. So memory contains both CPU as well as memory contains both instructions as well as data. Okay, data is pure data, numbers. Instructions are the what we discussed before, like load and store, which is interpreted and understood by machine language instructions, which is understood directly by the logic in the CPU. When we write programs, we, however, don't use machine language. We write programs in a high-level language. The high-level language that we will be learning in AP Computer Science is called Java. Now, we write programs in high-level language using a text editor, like say Notepad, WordPad, or a IDE environment, which is also an editor. An IDE, integrated development environment, includes an editor. We create programs using an editor, then we take that, and then in Java, we compile that to a bytecode. Okay. Typically, when you write a high-level program, you write it in a .java file. That .java file is compiled using another program called a compiler. Take a Java program, a .java file, compile it using a compiler. Typically, that compiler is a Java C. So it is compiled, and then it is converted to a .class file, which is a Java bytecode program. .class file. This Java bytecode program or .class file is then run by a virtual computer known as the Java virtual machine. Java virtual machine interprets the bytecode program and then can run it in any computer. The same Java bytecode program can be run in any computer because there's a specific interpreter for each of those computers. It could be a MacBook Pro, or it could be a Windows machine made by HP, or it could be a Linux or Ubuntu machine, right? You can get a Java program that can, for that machine, which can then interpret a particular class. Okay. Now, the fact that you can do this, write once and run in many different programs, in many different computers, is a key selling point for Java. Today, there are also Android-based cell phones which can run high-level Java-based programs. They, on a cell phone, they use a slightly different interpreter. Okay. Now, some of the programs that you should install, one of them is known as a JDK. This is the link from where you can download and install the JDK. You must carefully follow the instructions. In the follow-on class, we will discuss it. Then we also use BlueJ, which is an integrated development environment. Download and install BlueJ as well. We will provide instructions on this in the follow-on class. Okay, so we understood the computer. It's a typical computer. We looked at the data and we looked at the address, right? So the data and addresses. So when a CPU wants to read data from memory, it places the address of the location of the data on the address bus, and then the memory will respond with the data in the data bus. Okay. Now, when the CPU wants to store data, it will place the location where it wants it stored on the address bus, and also the data it wants stored in the data bus, and it will go into the memory. Now, data can also be sent from memory directly to the display, and also directly from the disk to the memory. Okay, so the actual dealings of how this works, I guess I provided a high level view, but this is not all of it. These are very involved. The parts and workings of a computer have evolved over the years. But what you need to understand is how to make high level programs and how these programs can be understood and interpreted. Okay? And then you need to be able to download and install. These are again some of the links. We have apexams.us computer science, and you can go to Play Store and download our app. But what is also important is to go and look up the course in for AP Computer Science in College Board, and then also download the JDK. These are all the tools that you will need as you progress through this course, and we will help you download all these things, install them. You can attend our tutorials, start making programs. Thank you.